Okay, for this question, you need to go looking for your formula booklet. And when you look, you shall find the binomial series. Question asks for ascending powers of x. Ascending means going up, so the increasing powers of x. So if you look at your booklet, you're looking at b, and making b in terms of x for this problem involves making b equal to the right-hand term, the x term, and making a equal to the other term. So b has to be a negative. And now you are just substituting into the formula in your booklet, a being 2, n being 7, and b being negative x over 2. So in goes all of those three numbers, and you write it out in full, completely unsimplified. So we're only doing the first three terms. This is the x squared term written down now, and we leave the rest. 2 to the power 7 is 128. Now we have a negative x, so we're going to put the negative in. I'm going to sort out the 2's first, and then 7 choose 1 is 7, so I'm not going to do the full calculations. 7 to choose 2 is 21. If I do the squared x term, I get x squared over 4, and the negative disappears because I'm squaring it. Finally, I get my three terms. It's taken a bit of number crunching to get here, but I've earned 4 juicy marks in accomplishing this. The fifth mark, you are asked how you would estimate 1.995 to the power 7. Well, you need to make the guts of the bracket equal to the 1.995. And you do that, you find out what x value you would get. That's the thing you need to do. If you rearrange the equation, you'll get x over 2 is equal to 0.005. Doubling both sides gives you x equals 0.01. And the answer is to substitute x equals 0.01 into this equation, and it will give you your estimate. Here is the mark scheme in all its glory. The first mark comes from attempting to use the formula in the booklet. The second mark is from getting 1, 2, 8. The third mark from negative 224, and the final mark for positive 168. For part B, you need to find the value of x and state that you would substitute that into the answer that you found above, namely into the expression that you found for the approximation.